Good afternoon, everyone. Thanks for joining us today. Just to cover off on some housekeeping things real quick, today's session is being recorded. So you'll have the chance to watch this available on demand starting sometime tomorrow, and we'll send that link out when it's available. We definitely want to kick off today's uh, event with a quick little poll, and then we'll jump in to introductions. So you can jump in. The quick question is, does your company currently use a risk-based inspection method to prioritize inspection efforts based on the likelihood and consequences of asset failure? I'll give you all a couple of seconds to jump in with those. All right, I still see some answers coming in, so we'll give that a couple more minutes. Again, today's session is being recorded, and we do have a place for you to jump in with chat or ask some questions. Definitely want this to be a collaborative and interactive session today. But with that, it looks like, yeah, we've got a good mix of between both. So pretty heavily on the RBI side. So that'll help us frame our conversation for today. Without further ado, let's jump in with some introductions. My name is Michael Rowell. I'm the Director of Revenue over here at ARIX Technologies, and I'll be serving as your moderator today. Joining me are Diana Liu and Joe Nunez, and I'll go ahead and let the two of you introduce yourselves. Joe, why don't you take off?
Yeah, so my name is Joe Nunez. I've been with ExxonMobil for 18 years. Currently situated at one of our manufacturing facilities and in a static equipment engineering supervisor role. Throughout my career, I've spent most of it in various manufacturing facilities, all with a focus in the mechanical integrity space, either between engineering or other opportunities that I've had over those 18 years.
Great, thanks, Joe. Diana?
Hi everyone, thanks for joining us. I'm Diane, the founder and CEO of ARIX, and before ARIX, I also used to work for an oil and gas major, did a couple roles on their in coordination and supply, and then a role in asset integrity at one of the plants as well.
Great, thank you all so much. The topic of conversation today centers around corrosion. Obviously, it's a big piece of what we struggle with at some of these facilities, and specifically, CUI, I think, is where we'll get into a lot of this. It's corrosion under insulation. But I think before we dig into all of that, y'all, let's talk about kind of what that true cost might look like. I mean, we like to float around some of these big numbers about billions of dollars per year, but that kind of becomes unfathomable. So, Joe, you're probably closest to this out of all of us right now. What's that look like beyond these kind of big, esoteric, kind of giant numbers we look at all the time?
Yeah, no, I kind of actually really liked the way that this was framed up initially, because how do you get your head around how big of just an issue or an opportunity is corrosion in the petrochemical industry and even beyond that. And you're right, I know you guys have been able to source some of these studies and they kind of throw dollar amounts on it, but that really doesn't connect. The way I try to frame it up, and this is, we kind of have these discussions with newer inspectors or engineers that come into our company or maybe seeing the industry for the first time, and you want to frame up like, how big is this thing? We make the simple connection. The whole reason, our branch of the company we're in even exists is because corrosion is a thing that has to be managed and is out there and is extensive in our facilities. I mean, you can imagine, for most of the folks here, if the companies we worked for didn't have to invest in it, they absolutely would not. Like, they're not out here trying to do anybody a favor. And in order for them to go and run the products they run, and obviously be able to make the money they make in our industry, we're out there having to maintain the equipment that we put this stuff into. And like you said, CUI is a big one we deal with, so that's just by nature of existing out there, but obviously the other types of corrosion we deal with. And so when I frame up, for people that are new to the industry, just how big the opportunity here is, it's as big as the fact that we have to even be staffed pretty extensively, based on your facility in order to, find the issue, analyze the issue, and then be able to manage it and prioritize how we go after it. Because obviously none of us have infinite budgets to just fix everything right away. And you're often looking at staging this years out, and you just kind of continuously do that. And so that's how I get my head around it, and how I try to make that connection for folks, to I think bring it home for them the way they think about it.
Yeah, thanks for that. Diana, what are your thoughts? You've seen this firsthand as well.
So definitely not as much experience as Joe, so thank you for that. And I think what I can add is, aside from even the plants themselves, having worked in headquarters at one of these companies, it has knock-on effects down the line too. So, if a plant's having an issue, they have an army of people mitigating the issue, solving it, really focused on preventing incidents and safety. But then even an operational thing that has no impact on safety, it's going to impact the financial bottom line of these companies. It's going to impact other people's jobs, who are scheduling the logistics of the crude coming in, the products going out. So I think there's a lot of effects that aren't even truly captured by some of these numbers.
Yeah, that's a really good point as well. The knock-on effects or downstream effects, no pun intended, from all of this is really significant. So, given kind of the size of the problem and the solutions to it that we're looking for, what are some of the challenges? Joe, we'll start with you. Of kind of like, you've got this big staff, you're trying to mitigate as much risk as possible. What are the current challenges that maybe you might face in that kind of situation?
Yeah, I think the way kind of I look at it is, I mean, the challenges are the same as the challenges of getting any sort of information to make a decision in an environment where you really can't get all the information you want or need sometimes. So it's the need to be able to decide on how you're doing it with incomplete information, and a lot of times it's incomplete. There's a couple different reasons why it might be incomplete. It could be the ability to access, to get access to where the issue may be. It could be as simple as you just don't know what's going on in a certain spot, and you may be relying on guidance that's available in industry documentation, or from subject matter experts you may engage in the problem. But we don't always get it 100% right, and sometimes you just may not be aware that in that one spot over there it's going on, and that just didn't hit the radar for anything. And then it's just the actual implementation of going to collect the data you need to make decisions that can make it difficult as well. For 100+ years, the way you got this information is you got a crew of folks who were specialized in an inspection technique together, and you needed to give them access. They needed to be trained to come into your facility. They needed to get access to where the issue is. All of this, of course, adds to the cost of acquiring the data, or the information that you need. And depending on how, contained or extensive the issue is, plays directly into how your ability to get the information that you need. So I think that's probably the big, what makes this challenging is that you can never really get complete information. And because doing that can be cost prohibitive for like everything that you have to deal with. It's really only in very specific, highly critical, situations where the cost would be justified to get 100% information. Most of the time you have partial info, and you have to do the best you can with that.
Yeah, Diana, anything to add on that?
I think Joe said it really well. I think ultimately it boils down to cost. And it's like if people had unlimited budgets and unlimited people, yes, it'd be awesome to get all this data. And then you run into the issue of you have too much data. How do you process it? How do you actually get the useful insights out?
Yeah, great. Thank you both. I think one of the things that would help before we jump further into kind of how, the industry, what is a very resilient and innovative industry, handles these challenges. Let's talk a little bit more about kind of a specific issue with corrosion. And Diana, I think this time I'll start with you just to mix it up a little bit. But if you can talk to us about your experience with CUI and kind of what the issues and challenges are for this kind of unseen threat.
Oh gosh, good question. And it's a little intimidating going before Joe, I won't lie. So CUI, back in my limited time at the plants, definitely was a big issue for us. I think what is scary is that this is hidden. Like I said, it's kind of underneath all this insulation. You know there's corrosion, you know it's happening somewhere, and you can't see it. And it's just, are you looking at the right pieces? Kind of what Joe said earlier, are you, really diving in and inspecting the right areas? You don't have unlimited funds to go and strip every single pipe all the time. You don't have the funds to be able to re-insulate all the time. How are you sure that you're really doing follow-up inspection on the right areas and you're not missing the areas of most concern? Especially if the outside insulation looks beautiful.
Yeah, Joe, what would you add from your experience?
Yeah, I think, and I think you did fine, for the initial there. CUI, in my experience, tends to be one of the just bigger corrosion mechanisms that's present in a lot of our plants. It's not uncommon, it has a specific range of temperatures at which, it's most likely to occur. If you, read the industry documentation on that, and for a lot of operations within our industry, they're kind of right in that sweet spot. So this is something that, for lack of a better term, tends to eat our lunch, if you will, when it comes to managing corrosion. And it's everything that I mentioned before, and what Diana, brought up again and highlighted, is that it's so much, it's so big, it's so pervasive. This is not something that you can go and 100% inspect everywhere. So the challenge for us on the actual owners, users, engineer, inspector side is getting our ducks in a row about really understanding the process, and then being able to identify those key areas that we want to go look at to be most efficient with our inspection budgets. If you kind of just go willy-nilly, then not so much that you maybe mess up the information you need for one specific inspection, but you'll start to eat into your budget to get other inspections and begin to, I think, almost self-consume, your ability to manage your entire mechanical integrity program. So you because of how big this is, you really do need to use the information you have at hand and be very targeted as best as you can with that info on where you're going to look for it.
That's really great. Appreciate that feedback from both of you. So, it's such a pervasive issue, as y'all have highlighted for us here. I would imagine that, a lot of people have tried to figure out, like, okay, to your point, Joe, it's, you need a screening mechanism in order to kind of direct your inspection dollars and not just eat everything up. What are we doing today? What's kind of, how are we managing and preventing this issue, or hidden problem that we can't lay eyes on?
Yeah, it's so I will say that there's been a lot of industry research in the area about where CUI occurs, and if you go to industry symposiums or networking opportunities, you can touch base with a lot of, I think, folks who would be subject matter experts in this area. The way I've seen it done the most is that you either following industry guidance or the guidance that's been developed by folks who are SMEs in this role, is that you take the limited information you have, not just from an inspection standpoint, but the information you have regarding the process, like what you're actually running in the equipment, what your unit is doing from a temperature standpoint, and that information needs to all come together. And then using the guidance that's available from these different resources, it allows you to try as best as you can to target where your initial looks are for something like CUI. If I have, I'll just, as an extreme example, if I have a circuit that swings temperatures, into and out of the range where CUI may be active, I know that I'm probably going to want to, focus on certain areas over there relative to something that may only intermittently get into the range, or maybe they're more consistently that I've, been able to manage a little bit better. So that's just as one example. There's things that this is the kind of information that feeds in. So you can't just go, oh, okay, well, I have a thickness reading here. And so now I've got enough insights to target myself better. You need to see the whole picture on the unit, bring all that information to bear. Otherwise, you'll be shooting blind, and then you kind of get into that kind of negative feedback loop of really cannibalizing your mechanical integrity budget in a very inefficient way.
Yeah, and Diana, for you, since you have experience at ARIX, I'll maybe shift to some of the newer technologies that are out there for NDT, and kind of talk to us a little bit about kind of what robotic solutions have started to look like that can complement what Joe just described.
Sure, and I think I really like how, again, Joe mentioned trying to target and do, deploy your resources more effectively and in the right locations. And I think robotics can really help with that kind of in twofold. One is, it is difficult getting to a lot of these areas. There's so much pipe, so much, stuff out there that it needs to be a partnership between what's currently done and just newer tools, and giving those really good, really smart inspectors the tools to get more pipe for kind of the same work. We can't overwork them to death, and robots are really good at that. Another one I like to think of a good use case is, I think on a previous slide you mentioned the continuous scanning, and Joe hinted at, trying to get more data, just being able to get a more holistic view of the pipe. The analogy I like to use is, if you have, say, a 2-acre field, you lost your wedding ring in the field, the last thing you want to do is go with a little shovel, and dig up the entire field and push it through a filter to find the shovel. In some ways, that feels like what we're doing right now in the industry, or at least back when I was there. You're trying to get very detailed looks at everything and extrapolate from that. But instead, if you're losing your ring, you want to go with the metal detector first. Not get the exact data points, the exact digging up every single spot, but wait until the metal detector beeps and just go back with a shovel and dig that area. It's much more efficient and effective deployment of capital, of people's time. And I think that's where robots can be really helpful too.
That's great feedback. I'll take this moment to kind of survey our audience today and ask, is your organization currently considering the adoption of robotics for NDT and corrosion detection? Go ahead and give a couple of seconds for people to answer. Kind of see where we are on the. Great, we've got some people already using it, which is great to see. Some people not looking at it right now, which is also totally understandable. There are a lot of really good methods out there on the market, and we partner with quite a few of them.
Yeah, I think maybe while they're answering that, I might add just as kind of to build off of what Diana said.
Yeah.
Robotics, I think, definitely is something that we are seeing more and more. We have brought in a couple different robotic opportunities into the facilities that I've supported, and I would say as of right now, they've, I think, found the most success with very specific applications. Like, you get robots you can put into your boiler and they'll inspect boiler tubes, or you get the robot you can put on a really long run of offsite pipe, and as long as the pipe supports aren't too complicated, it can just crawl for miles and miles. I'm sure if there's any pipeline folks that are like listening to this webcast, they're probably thinking, well, isn't ILI the first robotic inspection we've been doing that for forever? And it's like, you got to give credit where credit is due. But I think what they maybe already knew, and what we're finding out as we kind of open ourselves up more and more to the advanced robotics and the specialty inspection it can bring, is the flip side of the problem, where I spent all this time in the earlier talking about you don't have enough data and you need to be efficient with your resources, and now it can be something that you have to balance as too much data or too much noise and not enough signal, because are you really chasing down something that's a concern, or is it you have to balance the other side of the coin, where the data can obfuscate what you need to go after as well. So that's something that we've been learning, kind of catch both sides of it. Something we've been learning, that we have to manage appropriately.
Absolutely. Well, great. It looks like we've got a good handful of people that are currently using robotics, some that are exploring it, and some that are not considering at the time, and probably for a lot of the same reasons that you're describing all across the board, Joe and Diana both. So moving along, um, Diana, we've got a picture of our robot here. So why don't we talk about kind of your vision for the ARIX robotics solution, and kind of what got us started here, kind of go from there.
Sure. So I think we, like Joe, came from the industry, and we're really looking for something to help us, help us do our jobs better, help us do it safer, give us another tool in the tool chest that we can use to handle this problem and just to help with it. So what we did at ARIX is we tried to partner with the customers and really get their feedback from the beginning of, hey, this is what we think, from our experience. Now, please tell us all the ways that our baby's ugly so we can fix it. How can we design this to be more effective in the field, and to just point, a very targeted use case. So we're not trying to fix everything. There's not going to be a silver bullet that can do pipe inspection and tank inspection, and flare stack inspection. That'd be silly. If we really focus on, here is a CUI problem that that is eating our lunch, as Joe said. How do we build a robot to help with that first and foremost, to deliver the data that's needed without giving so much data that's all noise. A very specific use case fit into the existing method, so it's not a complete management of change overhaul. And at the same time, allow the inspectors out there to do their jobs, safer, faster, more efficient, and reduce harm to them in the process. These are really, really smart people who know their job well, and we just want to let them do their job even better, the way that they want.
Yeah, and imagine in both of your careers in these facilities, you've seen kind of, we've already talked actually about the scale of the problem and kind of how this all works together. And Joe, to your point, given the miles and miles of pipe at even just a single refinery, we could go snowblind with too much data. So can y'all talk to us a little bit about kind of how that scaling can work and where that balance might be in these kind of scenarios?
Yeah, you want me to go, Diana?
You go first. Yes, I feel like I've been talking.
No, that's okay. Yeah, I think I mean, it's a balance. So at the end of the day, I think you had mentioned in the earlier poll that most of the audience is fairly versed in risk-based inspection methodologies that the industry has out there. So I mean, really, when you think about it, it's this is just going to be another tool in the toolbox that provides the folks in the end user organizations, like where I'm at, with information. And what we really need to get out of that is like, what is the, like you said, the likelihood, and then the attached to the consequence we've assessed, and basically allow us to take this component that we're looking at, understand its history, where it's at right now based on the data we've gotten back, and then stick it back into the list of things we're managing in the right priority order relative to everything else. And ideally, if you get it completely right, then you won't spend 1 cent more or less than you needed to based on that priority list to manage that. And of course, no one ever does it perfect, but that's kind of like the utopia you're shooting for. And so as we scale, to your comment, we have robots and other solutions that allow us to look at so much more of this in shorter timeframes than we used to. Because again, for over 100+ years, the way you did this is you sent people out to look at the issue where you told them you thought it was the most important or the most concerning. And sending people out can only get you so much information. But when you open up the ability for these automated inspection techniques or these robotic inspection techniques to come in, you can get so much more in such a short amount of time. The real key for end users like myself is you've got to turn this like avalanche of data back into the simple, like, what is the status of my equipment and how do I correctly prioritize it? Because I want to either know I have to do something to address it now, and if I don't, I would like to, as best as I can with my prioritization, target when I might have to come back and look at it again in the future, and I would like to not do that more than I need to. And that's the challenge of scaling. I think companies that supply robotics and robotics inspections are just there, it's kind of like this exponential takeoff. And for folks here on the end user side, it can be it can be like a tsunami. It's like you're being inundated with, all of these inspection techniques that can just overwhelm you with data. And it's really been something on our end that we've needed to get our heads around and make sure that we're working with companies that can help us ingest that correctly and process that data so we're getting signal, not noise. And then, we're not changing our risk-based inspection techniques we're still using those same techniques. So ultimately, whatever this new technology is, has to be translated into the same systems we've been using for, the last 30 years at this point, since RBI really kind of has hit the scene and taken off. So that's what we've been balancing, I think, in the answering the question of how do we scale this and scale it appropriately.
Yeah, that's really good feedback. And Diana, I'll let you chime in with kind of, we've got one of our case studies on the screen and it talks about scale, but what are your thoughts?
I think Joe hit it that on with, with all the data, you need to be able to fit it into the existing systems. Like, these are massive companies and they're all going with a fantastic North Star. So, Joe, like you said, it's not gonna be perfect, but at least you have a vision of where everyone wants to go. And I think robotics companies, and not just robotics, but any new tech, needs to know how you can actually fit in and help, and not just like, ooh, shiny new toy that doesn't add any benefit. It's how do you actually fit into the risk-based inspection profile and make someone's job easier. And I think a lot of times robotics helps with the probability piece of that. So, the consequence these companies know very well when they go into risk-based inspection, what the outcome is, what are the things that can mitigate on that side. But better inspection or different inspection can be additional inputs into the probability, of something happening, and that way they can adjust their risk profile based on that. So I think that we've seen multiple companies do a fantastic job of thinking through that and working towards the future in that. And like I said, the case study, we did a recent job earlier this year with a company that's very much on the forefront of a lot of the robotic use. And in this case, it was not just, how can we help with the probability piece of it, but also how can we save them cost and time at the same time. So this was a fairly long pipe, insulated piping. It wasn't astronomically high, but difficult for someone to reach from the ground level. And we were able to perform the scan for them at a 70% discount to them over what they would have spent, 13 times faster. So they were able to use that additional cost and time to do more inspections on other pipes, and further reduce their risk. So it just lets them hit more pipes, and by doing that, they can actually reduce their overall risk profile. So we really enjoyed working with them on this too.
And Joe, to your point, the technology has changed a whole bunch, and things need to fit in. What are you seeing in terms of kind of advanced screening methodologies that you've kind of liked or seen been successful and fit in to that?
I mean, we've tried just about. There's some. I mean, with how big our company is, I mean, if there's a new technology through one of the major, inspection houses, I mean, we've just about tried all of it. And so it really, it's not, getting over the hurdle of, oh, there's this new technology and it could be more efficient and we should try it like that. That almost at this point sells itself, for a company like us. I think the challenge that comes back to is, what are the results we're going to get from this technique? How do we translate that to match up with again, we got to, take this thing and put it in the list with everything else. And we're not inspecting everything the same way. So the burden, the learning curve on the end user side for us has been, how do we take the information that's now available to us through these new techniques that may be pushing us way beyond the capabilities we used to have, and then reeling that back in so we can be apples to apples as we prioritize our risks through our risk-based inspection programs. And that's where when we talk with the different companies that may bring forward new technologies, the discussions with them specifically are on the technology itself. But in-house, the discussion is, how do we use these results and fit it into what already exists? And after we do all of that, do we see the efficiency, the time savings, the cost savings that was promised so that's where we spend our time.
Diane, any additional thoughts there?
No, I think even more than just Joe's company, we see this working with multiple companies. I think it's a very consistent thing in the industry, and very much kudos to the industry for thinking that way.
Absolutely. And as we start to bring things to a close, Diana, I definitely want to give you a chance to kind of highlight, if I can get my slide to go forward here. To highlight kind of, the ARIX approach to both this kind of efficiency and efficacy problem, but also kind of how we look at the problem of getting too much data and what we can do with it.
Yeah, so it's a good and bad thing, right? All the additional data, like Joe said. So I think one of the first things we realized with robotics is as you're getting more data, a lot of the heritage systems from these companies are set up for the heritage methods of the data that they currently get. So what really helped, we found, was provided them that link between robotically collected data and their systems, and basically giving them a way to store this robotic data, which might be continuous, which might be visual, video sequences that existing databases aren't equipped to store. So this allows, this one, for instance, with a screenshot of one of our portals, we were able to scan the pipe with the robot, and while the robot's moving, it actually recreated the pipe in 3D space. And over that, we could overlay our data, whether it's numerical numbers or links to videos, and this makes it a lot easier for that huge amount of data to be ingestible. So instead of looking at massive Excel sheets of numbers, which even as an engineer myself, it makes you kind of go cross-eyed. Now you have a very nice visual view, and you can say, hey, this area looks a little off. Let me pinpoint, just dive into this area and kind of ignore all the areas that's good. So we tried to create this with the end user in mind. And of course, this is something that we love feedback on with end users like Joe. And I think this is something that with better analytics, better software systems, it can help these companies better ingest that vast amount of data and pull out the shiny nuggets that they need to follow up on, instead of the 10,000 data points that otherwise would just live in an Excel sheet.
You talk about analytics, so I think I'll use that as a perfect segue to let you kind of dive into our analytics platform a little bit, and how it helps that snowblind problem from all the data that we've talked about.
Sure. So I think this goes back to the probability piece that kind of Joe hinted at and I mentioned earlier, where a lot of the corrosion models right now, these companies are doing as much as they can with risk-based inspection, but just systems sometimes are limited to Excel or whatever systems exist already. But being able to leverage all the more advanced machine learning capabilities, AI capabilities, just by pulling in additional variables that you may not have thought would impact corrosion. Or maybe what we see is like the engineers like Joe, the inspectors, they know in their gut what pipes are the ones that are most of issue. What are the things that actually impact it? And they just need the data to support them, so they can go to their manager or the budgeter and be like, hey, we need to inspect this pipe because I know it's gonna fail. I know the data doesn't show it, the models that we currently have, but because of X, Y, and Z, I know this is going to have a bigger issue. So what we try to do is build in the capability for them to dive into that, to build in the ability to pull in all these variables that you may not have thought immediately. So we're actually working with one of the major oil and gas companies on this, and being able to pull in all the different variables that they've never really looked at as part of their analysis. And the ability to do that has given them much more interesting insights of like, hey, we never thought about, this is the area to do more follow-up inspection, or this is the area that we should do robotic inspection, or this is the area that we don't even need to do robotic inspection. We can dive straight into the detailed inspection. So I think you can't really have robotics without a lot of this data analytics, and vice versa. They really help each other out. And what's been awesome to see is the industry really moving in that direction on both.
Absolutely. Well, as we move to Q&A, I'll ask you each just kind of for any closing thoughts. We do have some questions from the audience already. I want to take a minute to say thank you both for the conversation today. It's been really enjoyable and an honor to kind of host this for us. But Joe, before we move to Q&A, anything to say in closing?
But no, I mean, just I think we covered it really well. I think more and more robotic solutions like what you guys have and like what a bunch of other companies have brought forward. I mean, they really are going to unlock new capability for us, but that's just going to run into the inertia of the industry that we're in, and it's just inundating with too much info is almost just as bad as not having enough info in order to really understand the risks and keep them prioritized correctly. And so that's just the challenge ahead of us is, we adjust to all this new info and new techniques, and over time, the industry moves forward with better, more efficient inspections, and it allows us to handle more risk. And so that's really the promise here, I think.
Thanks for that. Diana, any closing thoughts before we move to a couple of questions from the audience?
I think Joe said it best. I'm not even going to try.
Great. So Diana, I think this one's probably best answered by you, but Joe, I'd love to hear your thoughts as well. What common misconceptions about robotic inspections do you commonly address with clients?
Oh gosh, I would love to hear Joe's thoughts after this. I think what we see often is people, have this awesome view of robotics, probably from movies and whatnot, of like, this is the silver bullet. This is going to fix everything, and I'm not going to use robotics until it fixes everything. Instead of seeing it as this is a tool in the toolbox, this is a hammer, this is a screwdriver, this is a wrench, and it's multiple robotics together that can help you. But at the same time, a wrench can't work without a person. Screwdriver can't work without a person. So we also need a partner with inspectors, the people who actually know what's going on, the engineers behind it, which kind of leads to another one. People sometimes think, oh my gosh, the robotics are coming. They're gonna, make us lose our jobs. When I think it's actually the opposite. If anything, it makes companies have more money for more inspections and therefore probably more people, which is a nice thing and win-win for everyone.
Yeah, I'd just build off of what you said. I think that even like the higher level, folks within our company, they see the promise of robotics inspection and just all of the new areas where we're pushing data analytics. And I think you think it's like, oh, this thing is out there and we're going to throw it out there and it's immediately going to bring these insights that we haven't had before. And it's thinking that, the data will immediately lead to AI, which will immediately lead to insights we haven't had before. And we're within short order going to be, completely turning over our entire RBI program, and we're going to be so much more efficient. And it's just, trillions of dollars and all this other stuff. And the reality is obviously much more nuanced. In the issue that you wade through is, well, now with too much information, if you just kind of let it run loose, you actually can't prioritize anything off of that as well. And so that's the biggest mismatch in, I think, expectations for the technology versus the reality of making it work up to this point. Now, I'm sure at some point we break through that and that no longer becomes the big mismatch. But at the moment, that's kind of where we've been stuck, trying to temper expectations against reality for, I think, the last couple of years as we've been really, plowing ahead in this space.
Absolutely. Thank you both for that. One last question, and then we'll close out today's session. Can you explain how robotics and PEC work together to enhance refinery piping inspections? And just in case our audience doesn't know, PEC is Pulse Eddy Current, and one of the technologies on board the robot you see in front of you. So Diana, I think maybe the question is best suited for you since it's a combo of NDT and robots. How do those two work together for this?
Sure. So PEC, or Pulse Eddy Current, like you mentioned, is one of the tools that is in the toolbox for inspectors today. So it is a way to scan through insulation without removal of insulation to look for corrosion under insulation. And we've been really lucky to work with one of the leading PEC manufacturers, Edify. So what the robot is able to do is put the PEC on board, and that way, instead of someone person crawling along the pipe and moving this PEC probe, the robot can help automate the PEC scan. So the inspector can stand somewhere safe, drive this robot around, get to the areas that they want to scan. And the benefit of the robot is now you can get to all of the nooks and crannies. You can go back and forth. You can get a much more comprehensive scan without someone being tired or in a dangerous environment. So I think it's going back to my analogy of the metal detector and the wedding ring in the field. It lets you be that metal detector, and PEC will give you a general view of this area, your remaining wall loss on the pipe's pretty good. This area, it's a little suspect. Maybe keep an eye on it. Oh my gosh, this area seems a little concerning. Let's go back to just that area and do follow-up inspection. And that way, instead of spending money on the entire, let's say, 1,000 feet line, you can be like, that PEC scan on the robot told me I need to dive deeper into this 10 feet only. And that saves you all the time and money that you would spend on the other 900 something feet that then you can use for other pipes and reduce more risk of, by inspecting more pipes.
Great, thank you for that. Well, Joe, Diana, thank you both again for joining us today and for a really great conversation. For those of you in the audience, if you scan the QR code in front of you, you'll be able to access the case study that we reviewed today. And in the next few days, we'll be sending you an e-guide that we're about to release. So once again, thank you for joining us, both of you, and audience members. Thank you for joining us and participating in today's webinar on robotic inspection and specifically corrosion under insulation. Have a great day. Thanks, y'all.